For this stream, it is going to be offline, so I will still be doing everything live. You'll see it all in real time, but I'm just going to do it offline and then upload it afterwards. So to start, or rather what I'll be doing today, is adding an action code. And like I said, action codes are generally, or at least as I'm using them, are for one-time events. So that would involve your movement. So for example, like a dash, a slide, or in this example, a jump. I already ran through all of this code just to do a quick test run, and I was actually having some weird issues where it was desyncing quite often. And I found out that's because here where I get the index of the last input the server sent to me, or the results of it, is I am finding that in my client motor states, which again are just inputs I've sent to the server. So I'm going to remove everything up to the one that the server processed, and that's what this line is doing here. However, this is removing too many entries. It is removing, what's weird is that it is removing the amount that the server has processed, or up to what the server has processed. So for example, I will send my input to the server, and then I will run it locally as well. The server will run that input, and then it'll send me the results back after that input has been run. However, it seems that what I'm sending back is the state of the transform before that input was run. So I need to actually get rid of this +1. And I have a feeling that it's maybe I'm not, I actually know why it's doing it now. I do, and it makes sense. It's because I am under the server here. I'm processing the input, and here's why I process the inputs on the server, and then I send the results or the transform back to the client afterwards. Except the physics haven't been simulated yet because that's done after the fixed update. So if I wanted to send the latest state, I'd actually have to do it after the on post fixed update. And I could do that, but just as easily I could also, instead of doing that and making a bunch of extra code, I could simply remove that +1 like I did, and we're good. So just explaining what mistake I made there and how I fixed it. Now let's go ahead and get to adding that jump. The first thing I need is some action codes. Right now it's just a byte, which is 0, and it doesn't really do anything. So I'm going to go to my states folder. I'm going to make a new script. I'm going to call it action codes and open that up. And let's see, I'm going to go back real quick and open this up just so I can copy the namespace here. I don't actually need any of this, so I'm going to get rid of that. I'm going to do public enum action codes, and I'm only going to have one action code to start. I'm going to do none equals 0, which means there are no action codes, and then jump equals 1, which is my one and only action code. Now this is going to be a flags enum, so I can basically stack action codes. Now with that said, if you wanted something else, let's just say we had a roll, that'd be a 2. And then let's say you wanted a sprint, that would be a 4. And if you wanted a dive, let's just say that'd be 8, because you have to, essentially, you have to multiply each previous value by itself, or by 2, sorry. I'm not gonna go into the details of how that works, but just a heads up, that's what you'd have to do if you wanted to add more. Now I am going to go into the motor, and I want to make a type here in the motor, and I'm going to call this private structure. I guess I'll just call it input data, and public boolean jump equals false by default. You can't put it as false because it's a structure. So I'm going to make that a class, because booleans are false by default, but if I add other things and I might want to flip it, I won't be able to do that in a structure. So this is all local anyway, so I'm not too worried about it. It's only going to be made once. So input data is going to be my class that stores, or rather inputs, which can be stored. And I'm going to actually go down here, and I'm gonna move first initialize and put it beneath my fixed update, just because I prefer to have all my Unity callbacks together where appropriate. And since this is kind of like fixed update, I'm going to keep it with the rest. So now I need to do update, and I need to make a new method. Not going to be anything fancy. It's just going to be private void check jump. Okay, and this is checks if jump is pressed. Really simple. This is going to be if input dot get key down, key code dot space. So my space key is going to be jump. And here's where I need to actually assign the input, but I didn't make a new instance of that class, so I need to actually do that real quick. So I'm going to do private input data stored inputs equals new input data. And this is inputs stored from update. And under update, I'm going to call check jump, because you have to do it in update, because as you probably already know, every key down will be registered in update, but it won't necessarily be registered in fixed update, because fixed update isn't called every frame. So if a key is pressed on frame 0 and fixed update ticks on frame 1, you're going to miss that. So we're going to go ahead and do that in update. And all we're going to do is stored inputs dot jump equals true. So if space is pressed, then jumped equals true. Now I need to go to where I send my inputs. So I'll go to send inputs, and keep in mind this is on the client side, which reminds me where I was just at for check jump, I should flag that as client only, because this can only be called on the client. Okay, so now going back down where I send my inputs, here's where I build my action codes. I also need to build them for my action codes. I guess I should say here's where I send my action codes, and now I need to actually build them. So I'm going to do action codes AC equals action codes none by default. I'm just going to do a little thingy here just to kind of separate the code. I'm going to do if stored inputs dot jump. Then I'm going to unset it, because we're processing it here. And I'm going to do AC, little line here, equal sign, action codes dot jump. So what this does, this little bar here in the equal sign, is it adds on to your enum. Like I said, it's a flag, so you can add on any number of enums as you like using this. So an enum can actually contain multiple values when it's a flag. Now I'm going to do action codes equals, and I need to convert it to a byte, because the action codes here in the state is a byte. And also I made my action codes a byte because I don't need them to be an integer, which I believe is a default, because that's going to be way more data sent. So I'm going to convert those to a byte and send them inside my state here. So we're adding the action codes to the state, but we aren't actually doing anything with them yet. So we need to go down to process inputs, where we add our forces, and we have to add forces for the jump. So I'm going to do a vector3, and I'm going to call it impulses. So I have my vector3 forces, which is just using force mode force, and I'm going to have some called impulses, which is going to be impulse force. And that's what I want the jump to be. So I'm going to do if, I need to actually read the action codes here. And since it's as a byte, I need to cast it to action codes. So I'm gonna do action codes, motor state dot action codes equals action codes jump. So if the action codes equals jump, then I'm going to modify the impulses force. I'm going to add on vector3.up, and I don't actually have a field serialized for this, so I'm going to do that real quick. I'm going to go up to my serialized field. I'm I'm going to do serialized field, private float, jump, impulse, and I'm going to set this to 8. This is how much force to apply as impulse. So let's how much force to apply as impulse when jumping. And now I'm going to go back down to process inputs, and I'm going to multiply vector3.up because that is your typical jump motion times jump impulse. And just below this, I'm going to do rigidbody.add force, impulses, force mode dot impulse. And I like to separate mine, like having one for forces and one for impulses. You can do it however you want. This is just what I like to do. And also I talked about flag checking. So I showed you how you could add on multiple flags and how to set it up in your enum state up here. But this isn't actually how you check for flags. This is doing a one-to-one check, basically saying if action codes equals this, then go ahead and jump. This isn't if action codes contains this, then jump. If you're looking for examples on that, Google, you always have Google. And I also have several projects which use enums like this that use them as flags, like FPS LAN does, Flex Network Transform does as well. And there's probably, you could probably open up any of my projects and find them in there. So if you're curious, just feel free to take a look at Google, of course. So what we have going on here is essentially whenever you press the spacebar and update, it sets a boolean to jump true. And whenever you are to send inputs to the server, it checks that if that boolean is set, then it'll unset it and attach the action code jump, and it'll add those action codes as the action codes inside the state, which you'll add to your queue, of course. You'll process locally and then you'll send it to the server, and the server will process it just the same. And I'm obviously not doing any like sanity checks here, like how often you can jump, are you grounded and stuff like that. I'm just trying to keep this simple. So let's go ahead and fix those compile errors real quick. Looks like I forgot to add that in, or probably made a typo. All right, hitting play. Going to try client host. Jump is working. So now I'm going to do a quick build. And while that's building, I'm going to open up Clumsy. And I'm going to give myself, let's just say 150 millisecond lag, which on localhost is a lot. That's about 300 ping. So just so you can see that I'm doing it right there. I'm going to start the editor up as a server. Let's go back here, hit client. All right, so I'm moving around. It's feeling really good. And there you go, I got a jump. And you can tell there's lag because you can see the delay from jumping here to when it reaches the server. Obviously it's jumping in real time on the client, so I'm gonna hit my keyboard a little louder so you can hear it. You can see it's reacting in real time. So if I actually bump this up to something crazy, it's like 450. See that? But I can still move around. Nice and smooth. Okay, great. I'm actually getting a warning here, calling the check jump function on the server. So I must have put this in the wrong section here. I forgot to actually wrap this if base.has authority. I only want to check the jump if I'm the client, because only the client will be needing to do that, of course. So knock that warning out of the way. All right, so now I'm going to go over to my player prefab, and I'm going to go to the rigid body, and I'm just going to freeze the Z position so it can't go forward and back. And the reason is because I'm going to add in a couple obstacles here, actually. And I'm going to make it so that they are in the way. And I don't want my player to roll off from this and end up rolling further back or whatever, because that defeat the purpose of the obstacle. I think a spear is pretty dynamic. I think that'd probably potentially create the most problems whenever you're trying to handle movement. But just in case, I will drop in a cube as well. So let's do 2, and let's just make it like 4 high and move it over here and move it down. Let's go ahead and make a new build, and we will try this out. And I expect it to work perfectly, no problem. The big thing with off movement is things you'll find the most hang up on is like hills and like edges. Edges are a big thing. So if your off movement isn't like perfect, you're gonna have some problems with edges. So I'm gonna go ahead and start up the client here, and he actually appeared inside the spear and he got popped out. So I need to probably adjust the spawn point a little bit. Right now it's moving 1-to-1, but I'm not simulating any lag. So let me get clumsy back up here, and let's go ahead and simulate that whopping 450 millisecond lag, which again is about a whole second, from there and back. Oh yeah, you see that? That's what I was talking about. You see how it kind of struggled a little bit? Now, I'm not terribly worried about that because, like I said, I'm basically running a 1000 ping right now. So I don't really care that much about things like that. So let's still go up to like a really high ping of 300. I know it says 150, but pings are typically round trip. So right now it's at about 300, which again is still ridiculously high. I don't think anybody would try, well, someone might try and play on a 300 ping, but I don't see the point. Yeah, so on a 300 ping, you can still see it's very reasonable. Not really running into issues. Very good. So 1000 ping definitely had a couple issues on edges. No surprise there. You cannot account for everything. If you're trying to make your game work with 1000 ping, I would say you are doing it wrong. I would not try to accommodate people on 1000 ping. But that's it. Now we have in our action codes, we have jump. You could add sprint. You could add all kinds of things in there. But as you can see, it was actually really, really easy to do. If you wanted to add in more action codes, all you would basically do is just add in a code here, check for the input like we did before, and if that input is pressed, you would add on the action code right here, and like before, you would just send it inside the state, and then under your process inputs, you would just process that action code normally. Like if it was sprint, maybe you want to double your forces or whatever. So the really cool thing about this is you're basically designing it for like you would an offline game if you're doing an offline physics game, but it's server authoritative and everything's like going between the client and the server. You're not really putting in any extra work. So that's a wonderful thing about this setup.